July 23, 1983, somewhere over Red Lake, Ontario. Air Canada Flight 143. Both engines dead at 41,000 feet, 69 people on board. No power, no fuel gauges, no checklist for this. The aircraft, a Boeing 767, barely 4 months old, had become the heaviest glider in history. The nearest airport was too far away. The only runway within reach was not a runway at all. It was a drag strip. Families were camped at the far end. 2 boys were riding their bicycles down the center line. An 132-ton airliner was descending toward them in absolute silence. The fuel had run out somewhere over the Canadian plains. Not because of a leak, not because of a mechanical failure in the engines, but because of a number, a single conversion factor, pulled from a laminated card that had worked for every other airplane in the fleet, had been used 3 times, by 3 different people, at 2 different airports, and every time, it gave the same wrong answer. The crew thought they had 22,300 kilograms of fuel. The tanks actually held 22,300 in pounds. A perfect numerical mirror, the kind that hides a catastrophic error behind the right-looking number. This is the story of how the most advanced airliner in Canada lost both engines at cruise altitude, and how a glider pilot and a former military officer turned a dead airplane into something that could still fly. But to understand how that happened, we need to go back to the ground, back before the engines started, back to a time when everything about this flight still looked perfectly normal. Air Canada's Boeing 767 was a different kind of airplane in 1983. Sleek, efficient, packed with digital technology that most airline pilots had never seen before. The old analog dials were gone. In their place, glowing cathode ray displays showed everything from fuel totals to engine parameters in crisp green digits. And for the first time on an Air Canada widebody, there was no flight engineer sitting behind the pilots. Just 2 crew members, side by side, with a flight management system tying all the data together automatically. It was the pride of the fleet, and the aircraft assigned to Flight 143 that day, registration Charlie Golf Alpha Uniform November, was only the second 767 Air Canada had ever received. It was barely 4 months old. The captain was Robert Pearson, 48 years old, more than 15,000 hours in his logbook. A seasoned airline pilot, but also, quietly, an experienced glider pilot who co-owned a sailplane and spent his weekends riding thermals over the Ontario countryside. That detail meant nothing on this July afternoon. It would mean everything by nightfall. Beside him sat First Officer Maurice Quintal, 36, over 7,000 hours, a former Royal Canadian Air Force pilot who had once been stationed at a military base in central Manitoba, a place called Gimli. He hadn't been back in years. As the afternoon crew prepared for their departure from Montreal, passengers filed into the wide cabin. Carry-on bags went into the overhead bins. A few travelers settled into window seats and watched the ground crews moving across the tarmac below. The flight attendants counted heads, checked seat belts, and sealed the cabin doors. From the outside, it looked like any other routine departure of Air Canada's newest jetliner. Red and white fuselage gleaming under the bright summer sky. But all was not well with this airplane, and it hadn't been for weeks. 3 weeks earlier, during a routine check in Edmonton, a technician had discovered that the fuel quantity gauges had gone completely blank. The system that drove those gauges, the Fuel Quantity Information System, had 2 independent channels. Either one could run the whole display alone. No single failure should ever knock out all 3 gauges at once. But a tiny solder joint inside the processor had started to break down, and the design meant the system never switched to the healthy channel. It stayed locked on the broken side. The gauges went dark. The technician found a workaround. He pulled the circuit breakers for both channels, then reset only channel 1. That forced the processor to reboot on the good side, and the fuel displays came back to life. But here was the problem. No spare processor existed. Air Canada's only backup unit had been sent overseas for a manufacturer test program. When it was recalled, it arrived defective, so the entire 767 fleet was flying without a replacement. The technician did what the rules allowed. He tagged the Channel 2 breaker with a yellow band, placed a placard above the gauges, cited the minimum equipment list, and logged his work. The MEL said the airplane could keep flying with one FQIS channel out of service. as long as the gauges still displayed fuel, and a manual dripstick check was performed before each flight to verify the readings. That was the trade-off. You lost redundancy, but you kept indication. And as long as you kept indication, you kept the airplane legal. The aircraft flew on under this condition for the next 2.5 weeks. The gauges worked. The dripstick checks matched. Everything held together until July 23rd. That morning in Edmonton, the gauges went blank again during a service check. The same technician repeated his fix. Pull both breakers, reset channel 1, gauges come back. He tagged the breaker, logged a fresh entry, and briefed the outgoing crew. But during that brief, a small misunderstanding crept in. The new captain heard that the technician had dealt with this before, and assumed the aircraft had been operating with the fault since the previous day. That wasn't quite right, but for the 2 flights that morning crew would operate, it didn't matter. The gauges were working. The dripstick was done. The airplane flew east to Montreal without incident. But after shutdown at Montreal's Dorval Airport, before the afternoon crew arrived, another avionics technician decided to investigate the problem further. Alone in the cockpit, he re-engaged the tagged Channel 2 breaker to power up both sides of the system at once. The gauges immediately went blank. He ran a self-diagnostic test called BITE, built-in test equipment, which confirmed the fault. He logged his findings. But before he could reset the breakers back to the way he found them, he was called away to assist with the manual dripstick test on the wings below. He left the cockpit, and the Channel 2 breaker stayed in. The gauges stayed blank, and the situation had now changed in a way that no one fully understood. When Captain Pearson and First Officer Quintal arrived for the afternoon shift, they met the morning crew casually in the parking lot outside the terminal. No logbook, no MEL in hand, just a brief conversation from memory after a long day. The outgoing pilots mentioned the fuel gauge problem and noted that the airplane had been flying with it for a while, with everything going smoothly. The new crew walked away believing that the gauges had been completely inoperative for days, and that this had been cleared by maintenance. That wasn't true. But within Air Canada at the time, there was a lingering belief that maintenance headquarters had the authority to override parts of the MEL, using some kind of master approval, perhaps even from the aircraft manufacturer. That belief wasn't accurate either, but it had persisted from an earlier era when such exceptions were occasionally made, and many crews still trusted it. So when Pearson boarded the aircraft and found the 3 fuel gauges blank, exactly as he expected, his assumptions were confirmed. The placard was there, the MEL reference was in the logbook, and when he asked the local technician about the discrepancy, the technician said the aircraft was okay to fly. The captain accepted it. To understand why what happened next became so dangerous, you need to know one thing about this airplane. The Boeing 767 was the first aircraft in Air Canada's fleet to use the metric system for fuel calculations. The gauges read in kilograms. The manuals were printed in kilograms. The dripsticks measured in centimeters and converted to liters. Every other airplane in the fleet, every DC-8, every 727, every other jet Air Canada operated, still used pounds. Canada was in the middle of its national transition to metric, and the government had pushed for metric instrumentation on the 767 as a matter of policy. But the transition was incomplete. Altitude was still in feet, speed was still in knots, and critically, no one at Air Canada, not the pilots, not the ground engineers, not the fuelers, had been trained to do manual fuel conversions in kilograms. Because on every other airplane, it was never necessary. The onboard computer did it automatically, and no one had clearly assigned whose job it was to do these calculations when the computer couldn't. With the gauges blank, the only way to know how much fuel was on board was a dripstick test, a physical procedure where measuring sticks are lowered into the wing tanks, giving a fuel depth in centimeters. Those centimeters are converted to liters, and then liters to kilograms, because the flight plan is built in kilograms. Down on the ramp, 2 ground engineers completed the dripstick check. 64 centimeters in the left tank, 62 in the right. They consulted the conversion tables and arrived at a total of 7,682 liters on board. Now, they needed to turn that into kilograms. One of them asked the fueler on duty for the correct conversion factor. The fueler checked his laminated density card, the same card used for every other aircraft on the ramp, and replied, 1.77. That number was wrong. 1.77 was the conversion factor from liters to pounds. The correct factor for kilograms was 0.8. The difference was enormous, nearly 120%. But no one caught it. The fueler's card had always worked for every other airplane. No one told him the 767 was different, and no one in the chain, not the ground engineers, not First Officer Quintal, who ran the numbers by hand, not Captain Pearson, who cross-checked with his Jeppesen slide rule, recognized that a liter of jet fuel weighing 1.77 kilograms made no physical sense. Jet fuel is lighter than water. A liter of water weighs 1 kilogram. A liter of jet fuel should weigh less than that, around 0.8. 1.77 was nearly double what it should have been. But none of them worked in metric. None of them had the instinct for these numbers. And so the math went through. 7,682 liters times 1.77 gave them 13,597 kilograms on board. The real figure was 6,160. They were off by more than half. But the number looked right. It felt right. And with no fuel gauges to challenge it, nothing stopped it. The crew subtracted their calculated onboard fuel from their target of 22,300 kilograms and determined they needed to add another 8,703 kilos. To convert that back into liters for the fueler, they divided by the same wrong factor. 8,703 divided by 1.77 came out to about 4,916 liters. They rounded up and ordered 5,000. In reality, they needed more than 20,000. When the fueling was complete, the airplane had roughly 10,100 kilograms of fuel in its tanks, not 22,300. And here was the cruelest detail. 10,100 kilograms is almost exactly 22,300 pounds. The number in the tanks nearly matched the number on the flight plan, just in the wrong unit. A perfect numerical coincidence that made the error invisible. If you like this video, take a moment to subscribe and ring the bell. It helps more than you'd think, and it means the next story like this one will be waiting for you. At noon, Flight 143 pushed back from Gate 47 at Montreal-Dorval. The 767 taxied out under bright summer skies and lifted off without incident. The short leg to Ottawa was uneventful, barely half an hour in the air. At Ottawa, some passengers got off, others boarded, and the crew prepared for the longer westbound sector across the prairies to Edmonton. Because the gauges were still blank, another dripstick check was required before departure. On the ramp, the procedure played out exactly as it had in Montreal. The engineers pulled the measuring sticks, read the depths, converted to liters, and then came the critical step, liters to kilograms. The same laminated card, the same conversion factor, 1.77, the same wrong answer. And this time, it confirmed that the airplane already had more than enough fuel. No additional fuel was loaded. The last gate closed. At 7 o'clock in the evening, local time, Air Canada Flight 143 taxied out from Ottawa into the warm evening light. The big twin-engine jet accelerated down the runway and climbed westward toward Manitoba. Captain Pearson was flying. First Officer Quintal was monitoring. The climb was smooth. The weather was clear. They leveled off at 41,000 feet and settled into cruise, chatting with an Air Canada engineer who happened to be riding in the cabin and had come up to compare notes about the new 767's systems. Behind them, the passengers relaxed. Some read, some dozed. Through the windows, the late sun painted the vast Canadian landscape below, rivers, lakes, and endless stretches of boreal forest. The airplane had less than half the fuel it needed, and every minute the tanks were getting lighter. Then, about 40 minutes west of Ottawa, a warning light appeared on the left engine display. Low fuel pressure. The captain's stomach likely dropped. With no fuel gauges and an entire chain of manual calculations behind them, there was only one realistic explanation. Something had gone wrong with their fuel. They were running out. The crew had already discussed diversion options during the cruise. Winnipeg was about 120 nautical miles ahead. They made the call immediately. First Officer Quintal contacted air traffic control and requested a diversion. It was approved. They received clearance to descend to flight level 350. Maybe they still had enough to make it, but only minutes later, as the aircraft started leveling off at 35,000 feet, the left engine flamed out. Silence on the left side. The airplane was still 65 miles from Winnipeg, and before the crew could even begin running the engine failure checklist, the right engine quit too. Everything goes quiet. The only sound is wind against the windscreen. The cockpit screens go dark. The hum of pressurization fades. In the cabin, the main lights cut out and the emergency strips along the floor glow to life. Flight 143 is no longer an airliner. It is a glider, 132 tons of aluminum, falling through thin air at 41,000 feet, with 69 people inside and no power of any kind. There is no checklist for this. The crew flips through the emergency procedures, looking for dual engine failure. The section does not exist. No one imagined a wide-body jet could lose both engines at once. Without the engines, the generators are dead. The APU is useless. Same fuel supply. The only thing keeping them alive is a small device called the ram air turbine, a tiny propeller that drops into the airstream and generates just enough hydraulic pressure to move the flight controls. It cannot power the screens. It cannot power the flaps, but it keeps the airplane flyable. Captain Pearson now does something that no airline training manual has ever covered. He flies the 767 the way he flies his sailplane. He holds the nose at what he estimates is the best glide speed, around 220 knots, and tries to stretch every foot of altitude into forward distance. First Officer Quintal grabs a notepad and starts calculating by hand. He has no vertical speed indicator, so each time air traffic control calls out their distance to Winnipeg, he writes down the altitude, computes how many feet they are losing per nautical mile, and projects how far they can still travel. The numbers come back fast, and they tell a brutal story. At their current descent rate, they will hit the ground more than 20 miles short of Winnipeg. Quintal thinks of Gimli, the old Royal Canadian Air Force base where he trained years ago. Twin runways, 7,200 feet long, about 45 miles away, closer than Winnipeg by 20 miles. He doesn't know whether the runways are maintained. He doesn't know if the base is even open. When they ask air traffic control, the controller can't find any current information about the site. But the math is clear. Winnipeg is out of reach. Gimli is not. The captain makes the call and begins a gentle right turn toward the western shore of Lake Winnipeg. Far off on the horizon, they can see Winnipeg's runways catching the evening sun. Close enough to see, too far to reach. In the cabin, the silence has not gone unnoticed. The steady engine hum that passengers never think about is gone. The air still rushes past the fuselage, but underneath it, there is nothing. Some passengers exchange looks. A few write hurried notes to family. Others sit still, gripping their armrests. The flight attendants move through the aisles, tightening seatbelts and giving instructions for the emergency landing ahead. As Gimli comes into view, the first thing Pearson notices is how small it looks. The runways are short, far shorter than Winnipeg, and from this distance, there is no way to tell what condition they are in, but they will reach it. That much is certain. The captain begins configuring for landing, but without engine power, the ram air turbine cannot run the flap circuits. No flaps means no way to slow down normally. The approach speed will be much higher than usual, and the nose attitude will be steeper. Quintal works the emergency checklist and moves to the landing gear. The main hydraulic system is dead. He pulls the alternate gear extension handles to release the uplocks and let gravity do the work. The main gear drops and locks with a heavy thud. The nose gear falls too, but does not fully lock into place. There is nothing more they can do about it. Now Pearson sees a new problem. They are too high. If he continues on this glide path, they will overshoot the field entirely. But if he pushes the nose down to lose altitude, the speed will build, and they will never stop on the short runway. He needs to lose height fast without gaining speed, and he has no flaps, no spoilers, no engine drag to help him. But he has something else. Years of glider experience, and a maneuver called a forward slip, rudder hard to one side, opposite aileron to hold the track. The fuselage swings sideways into the wind and becomes a massive air brake. In a glider, it is routine. In a 767, it has never been done. Pearson warns Quintal, then kicks the rudder hard right. The huge jet banks sharply, nose swinging 45 degrees off the center line. Passengers on the left see nothing but ground. On the right, only sky. But the altimeter drops fast, and the airspeed holds. As the runway rushes up, Pearson rolls level and guides the nose back toward the strip. And then he sees it. The markings on the pavement below do not look like a runway, because it is not one. The decommissioned airbase has been converted into a motorsport park. What they are lined up with is a drag racing strip. And at the far end, there are people, campers, cars, tents, and two boys on bicycles pedaling down the center line. There is nothing Pearson can do. He is committed. From the ground, the aircraft appears first as a speck, a glint of metal descending out of the bright July sky. Then the shape takes form, wings steady, nose pitched forward, no engine sound at all. People along the far end of the strip begin pointing. Conversations stop. The enormous airplane sweeps lower, accompanied only by the rush of air. The main wheels touch down in what would have been the touchdown zone. The captain holds the nose back for as long as he can. Then it slams forward into the pavement. The nose gear collapses. Metal scrapes concrete. Sparks fly in every direction. Spectators scatter. Campers dive for cover. The two boys pedal desperately toward the edge of the strip as the airplane skids toward them. Inside the cabin, the screech of friction is the only sound. The captain pushes the brakes with everything he has, every last ounce of remaining hydraulic pressure. The collapsed nose gear drags against the concrete, adding friction. The airplane decelerates. 12 agonizing seconds after touchdown, the Boeing 767 shudders to a stop. A short distance from the crowd, a short distance from the boys, a short distance from catastrophe. For a long moment, nobody moves. The air smells of rubber and scorched metal. The only sound is wind through the flags at the edge of the track. Then a voice comes over the PA. This is the captain. Evacuate the aircraft. The flight attendants open the doors and deploy the slides. In the front and over the wings, the slides inflate normally and passengers slide to the ground. In the back, the aircraft's nose-down tilt makes the slides too short to reach the pavement. Passengers jump. Some twist their ankles. Others catch them. People from the nearby campgrounds and racing pits rush forward with fire extinguishers. A small fire near the nose is smothered quickly. Within minutes, all 69 people are on the ground. No fatalities, no serious injuries. A brand new Boeing 767, both engines dead, no flaps, no working nose gear, has just landed on a drag strip and come to a stop before hitting anyone. When investigators arrived, what they found went far beyond pilot error. The official inquiry determined that no single person was to blame. But woven through every individual decision was something larger, something that had been building for months. Air Canada had introduced a metric aircraft into a non-metric fleet and trained no one to handle the difference. The responsibility for calculating fuel loads, once the flight engineer's job, had never been reassigned when the 767 eliminated that position. The fueling companies still issued density cards in pounds per liter. And the MEL had been undermined by years of informal overrides that left crews believing maintenance could waive its requirements. None of these facts were secrets, but no one had connected them. No one had asked, what happens when the fuel computer fails and someone has to do the math by hand, in a unit that nobody uses? In the aftermath, families of the 61 passengers arrived at Edmonton's airport to a flight that would never land there. At Gimli, the 767 sat on the drag strip, nose scraped flat, fuselage intact, surrounded by disbelieving onlookers and racing fans who had come out for an evening of motorsport and witnessed something they would never forget. Air Canada grounded its remaining 767s and overhauled its technical manuals. Conversion tables between liters, kilograms, and pounds were standardized and posted as laminated cards in every cockpit and at every fueling station, replacing the old density slips that had carried the number 1.77 for years. The casual practice of relying on a fueler's pocket chart was replaced with precise, temperature-corrected figures printed directly from dispatch software. Training programs were rewritten to ensure that every crew member understood the metric systems on the new aircraft. And the question of who was responsible for calculating the fuel load was answered clearly for the first time. On the technical side, Boeing issued service bulletins requiring changes to the FQIS design so that a single-channel failure could no longer prevent automatic switchover. The vulnerability that had allowed one weak solder joint to knock out the entire fuel indication system was eliminated. For the crew, the consequences were mixed. Captain Pearson was initially demoted for 6 months. First Officer Quintal was suspended for 2 weeks. 3 maintenance workers were also disciplined. But in 1985, both pilots were awarded the first ever Fédération Aéronautique Internationale diploma for outstanding airmanship, a recognition given to only 2 pilots in the world each year. When other crews were put in the same scenario in a simulator in Vancouver, every single one of them crashed. Quintal was later promoted to captain. Pearson continued flying for another decade before retiring. Quintal passed away in 2015 at the age of 68. And the airplane? After repairs to its nose, landing gear, and fuselage, Charlie Golf Alpha Uniform November was flown out of Gimli 2 days later. It returned to service and flew for another 25 years. On its final flight in January 2008, both Pearson and Quintal were on board. So were 3 of the original flight attendants. The aircraft was retired to the desert in Mojave, California, and later scrapped. Pieces of its fuselage skin were cut into 10,000 numbered luggage tags and sold to collectors. Today, a small museum in Gimli sits near the drag strip where the 767 came to rest. Inside, there are photographs, newspaper clippings, and pieces of the aircraft. And somewhere in the exhibit, there is a reference to a laminated card, a simple, pocket-sized slip that once carried a single number, 1.77. that nearly cost 69 people their lives. After the accident, Air Canada replaced every one of those cards across its entire operation. The new ones read 0.8. The drag strip at Gimli is still there. On summer weekends, cars still line up at the starting line. And every July 23rd, the people of Gimli remember the evening when a silent airliner appeared out of a clear sky and touched down among them, carrying 69 souls, no fuel, and one of the most extraordinary stories in the history of flight. Now, if you found this story as incredible as I did, check out this video right here, where another crew faced an impossible situation at 38,000 feet, and the decision they made in the first 90 seconds determined whether anyone would survive.